Okay, good morning students. In this session, the continuation of the previous session, designing of FIR filter by using different window techniques. So, last video session we have discussed about the how low pass filter using rectangular window. So, in this video session one more problem we will discuss in detail how to design high pass filter using Hamming window. So, the different functions window functions will discuss. So, the three members of cosine based windows, the three okay, the three members of, I think it is more dark, the three members of cosine based windows. Cosine based windows. Hamming window. So, Hamming window, the Hamming window function W of n, which is equal to 0.54 minus 0.46 cosine function 2 pi n by m minus 1. Okay. Similarly, for Hamming window, okay, for Hamming window, this one. For Hamming window, the W of n is 0.5 minus 0.5 cos 2 pi n by m minus 1, or you can use W of n 0.5 1 minus cos 2 pi n by m minus 1. Okay, this is a cos function. The Blackman window, the W of n is equal to 0.42 minus 0.5 cos of 2 pi n by m minus 1 plus 0.08 cos 4 pi n by m minus 1. This is for Blackman window. This is for Hamming window. Okay. So, now we will take one problem, design high pass filter, okay, using Hamming window, with a cutoff frequency, same will take with a cutoff frequency. So, the same high pass, previously low pass filter, now high pass filter using Hamming window with a cutoff frequency, say cutoff frequency of 1.2 radians per second and m is equal to 9, okay, odd only. So, what is the first step? Step 1. So, what is the desired frequency response? Is a high pass filter. So, do you remember the high pass filter frequency response? So, what is the frequency response of high pass filter. So, the C into e power minus j omega alpha for the range from minus pi to minus omega c and omega c to pi. Okay, first you should draw the frequency response of high pass filter, the desired frequency response of high pass filter. So, you know that so this side is minus pi, right. Omega c to pi minus omega c to minus pi. Okay. So, how do you write for this? Hd of omega is equal to c into e power minus j omega alpha, where omega is greater than or equal to this high pass minus pi to minus omega c, and omega is this one greater than or equal to plus omega c and less than or equal to pi. Okay, 0 otherwise high pass filter, sorry 0 otherwise, sorry, what is that 0? 0 for this one, this range, omega is greater than or equal to minus omega c and less than or equal to plus omega c, 0. So, this is a high pass filter, it pass this frequency, this is a pass band, the other will be rejected, that is a 0 otherwise. So, first you draw the frequency response of the desired frequency response, only will take c is equal to 1. Okay, step 2, now step 2. So, step 2 is what? You have to get Hd of n by taking inverse Fourier transform of Hd of omega, Hd of omega. To get Hd of n. So, by taking inverse Fourier transform of Hd of omega. So, what is the formula? Hd of n is equal to 1 by 2 pi. Now, the limits will be, what is the formula? Minus pi to plus pi Hd of omega e power j omega n d omega. So, carefully you have to apply the limits and integrate and apply the limits. Now, you can write 1 by 2 pi minus pi to plus pi e power minus j omega alpha into e power this one e power minus j omega alpha into e power j omega n into d omega. You can split the equation now. I write here 1 by 2 pi. Okay. So, what are the limits? Minus pi for high pass frequency, minus pi to minus omega c e power minus j omega alpha into e power j omega n d omega plus 1 by 2 pi. The limits will be plus omega c to pi and e power minus j omega alpha into e power j omega n d omega. Okay, next step 1 by 2 pi. Okay, the first one will be minus pi to plus pi, minus omega pi to omega c. So, you can integrate these two terms, minus pi to minus omega c. You can write e power minus j. So, this omega c, okay, n minus alpha minus e power minus j pi, apply this e power minus j pi n minus alpha, okay, plus e power j pi into n minus alpha minus e power j omega c n minus alpha divided by j into n minus alpha. Okay. Next step, 1 by pi into n minus alpha, constant term take it outside, so inside it will be e power j pi n minus alpha minus e power minus j pi n minus alpha by 2j, split the terms, minus e power j omega c n minus alpha plus e power j omega c n minus alpha by 2j. We'll get these two terms. So 1 by pi n minus alpha, so this term will be sine of n minus alpha into pi minus sine omega c of n minus alpha. So this, so after this you have to integrate and apply the limits properly. Now when n is equal to alpha, so you have to use L'Hospital's rule. Okay, in that case n sine of n minus alpha into pi by n minus alpha. Similarly here you will get sine omega c of n minus alpha by n minus alpha. So these two terms and these two terms becomes 0 by 0, so it will be indeterminate. So you have to get, so when it is not equal to alpha, this is the equation, this is pi into n minus alpha sine of n minus alpha into pi minus sine omega. So this term will be, so this is hd of n, okay, this will be for n is not equal to alpha. Okay, n is not equal to alpha, n is not equal to alpha. When n is equal to alpha, you use L'Hospital's rule. Use L'Hospital's rule. L'Hospital's rule. So in that case, the hd of n will be, okay, limits n tends to alpha sine of sine of n minus alpha into pi minus sine of omega c into n minus alpha divided by pi into n minus alpha. So in that case, for the first term 1 by pi, so limits so 1 by pi, take it outside, so use L'Hospital's rules for this one, you will get L'Hospital's for this one, so you will get only pi minus, for this case, omega c. Okay. So, pi by 1 minus omega c by pi. So, this is what hd of n equal to 1 minus omega c by pi for n is equal to alpha. So, now the window function, the window sequence for Hamming window so the Hamming window WH of n 0.54 minus 0.46 cos 2 pi n by m minus 1 for n equal to 0. So, now the finite FIR filter impulse response coefficients you can get by multiplying this infinite impulse response coefficient by the window function, Hamming window function. So, what is hd of n? You know that 1 by pi of n minus alpha into sin pi n minus alpha minus sin n minus alpha into omega c multiplied by WH function 0.54 minus 0.46 into cos 2 pi n by m minus 1 for n is not equal to alpha. Similarly, for n is equal to alpha, h of n is equal to 1 minus omega c by pi, 1 minus omega c by phi into 0.54 minus 0.46 into cos 2 pi n by m minus 1. This is for n is equal to alpha. So, the previous one is for n is not equal to alpha. So, now you substitute the given m value, given that m is equal to 9 and omega c is equal to 1.2 radians per second. So, alpha is equal to m minus 1 by 2. So, 9 minus 1 by 2 equal to 4. See here, both n and alpha are integers. N and alpha both are integers. So, n minus alpha into pi will be integral multiple of pi. So, you will get sine of n minus alpha into pi will be 0. Okay. So, now you substitute the values and find out the values of h of 0, h of 1 and all. When n is equal to 0, h of 0 will be minus sine of n minus alpha, we will write minus n minus alpha into omega c by pi into n minus alpha. Okay. Sine n minus alpha into omega c by pi n minus alpha. So, this term is not required for this, n is not equal to alpha. So, this is sufficient. So, you will get minus sine n minus alpha into omega c by pi of n minus alpha into the window function will be 0.54 minus 0.46 cos n pi by 4, cos n pi by 4. M minus 1, 8. So, 2 by 8 will be 4. So, n pi by 4. So, for n is not equal to alpha. Okay. This is for n is not equal to alpha, means n is not equal to 4. So, when n is equal to 0, substituted value here will be minus sine of minus 4 omega c is 1.2 by pi into minus 4 into 0.54 minus 0.46 cos 0 1. Okay. So, substitute and simplify, you will get, use calculator and put in proper mode and check the values 0.0063. Similarly, when n is equal to 1, h of 1 will be, check the values 0.0101. When n is equal to 2, h of 2 will be minus 0.0581. When n is equal to 3, h of 3 is equal to minus 0.2567. When n is equal to 4, because when n is equal to alpha, in that case the h of 4 formula will be 1 minus omega c by pi into 0.54 minus 0.46 cos n pi by 4, cos n pi by 4. So, you can substitute 1 minus 1.2 by pi, 1.2 by pi into 0.54 minus 0.46 cos n is 4 pi by 4. So, 4 will be cancelled, you will get, so this will be cos pi, you will get simplify 0.6180. When n is equal to 5, h of 5 will be h of 3 minus 0.2567, because we know h of m minus 1 minus n is equal to h of n. H of 5 Okay, this is h of 9 minus 1 8 minus n is equal to h of n. N is equal to 5 means h of 3 value minus. Similarly, n is equal to 6. H of 6 will be 2. So 2 will be minus 0.0581. N is equal to 7. N is equal to 7 is h of 7 is equal to 0.0101. N is equal to 8. H of 8 will be n is equal to 8. So it will be 0.0063. H of 0 is equal to h of 8. H of 0 will be 0.063. So the impulse response is, note, the impulse response is symmetrical with the center of symmetry at n equal to 4. So the impulse response symmetrical with the center of symmetry at n is equal to 4. So the magnitude response, now you can write the magnitude response. Magnitude response for linear phase FIR filters M is odd. Okay. For M is odd, the number of coefficients will be, so if M is odd, the number of filter coefficients is M plus 1 by 2 for symmetric and M is odd. So symmetric and M odd. Symmetric and M odd, then the number of coefficients will be M plus 1 by 2. If M is even, you know that the coefficients are, the filter coefficients will be, M by 2. For antisymmetric, I remember here, for antisymmetric, in MCQ, for antisymmetric, M minus 1 by 2 if M is odd, and M by 2 and M is even. Now next one, step 4, the magnitude response of FIR filter when the impulse response is symmetric and M is odd. what is the formula? Last problem also we solve the same. HR of omega h of m minus 1 by 2 plus 2 into the summation of n equals 0 to m minus 3 by 2 h of n cos omega of m minus 1 by 2 minus n. So, m is equal to 9, m is equal to 9, so which is equal to h of 4 plus 2 into summation of n equal to 0 to 3 h of n into cos of omega 4 minus n. Same. So, previously we saw the same only. So, h of 4 plus 2 h of 0 cos 4 omega plus h of 1 into cos 3 omega plus h of 2 into cos 2 omega plus h of 3 into cos omega. So, the magnitude response h of 4 plus 2 into h of 3 into cos omega plus 2 into h of 2 into cos 2 omega plus 2 into h of 1 into cos 3 omega plus 2 into h of 0 into cos 4 omega. Similarly, the transfer function of the filter is given by h of z. It is a system function in digital filter. The summation of n equal to 0 to m minus 1 h of n into z power minus n. So, symmetry function in the previous same problem is solved, same method. So, write summation of n equal to 0 to 8 h of n into z power minus n. You write summation of n equal to 0 to 3 h of n into z power minus n plus h of 4 into z power minus 4 plus the summation of n equal to 5 to 8 h of n into z power minus n. So, you know the symmetry property. So, that you can write summation of n equal to 0 to 3 h of n into z power minus n plus h of 4 into z minus 4 h of 4 into z power minus 4 plus, so you can write the summation of n equal to 0 to 3 okay 5 to 8 0 to 3 h of n into z power minus 8 minus n. So, now you can simplify again summation of n equal to 0 to 3 okay h of n common term you take z power minus n plus z power minus of 8 minus n plus h of 4 into z power minus 4. So, now let h of z is equal to y of z by x of z, which is equal to h of n, we need to know h of n, yeah, is equal to h of 0 the 0 plus z minus 8 plus h of 1 into z power minus 1 plus z power minus 7 plus h of 2 z power minus 2 plus z power minus 6 plus h of 3 into z power minus 3 plus z power minus 5 plus h of 4 into z power minus 4. So again you can write y, finally the y of z term will be h of 0 common term you can take, okay, x of z, x of z plus z minus 8 into x of z plus h of 1 into z minus 1 into x of z plus z minus 7 into x of z plus h of 2 into z minus 2 into z minus 2 into x of z plus z minus 6 into x of z plus h of 3 into z minus 3 into x of z plus z power minus 5 into x of z plus h of 4 into z power minus 4 into x of z. Okay. So now at the end of this session I would like to give one problem for you. You try to solve, okay, and submit. Design low pass filter with this is a given problem with 11 coefficients, with 11 coefficients for the following specifications. For the following specifications: pass band edge frequency, pass band edge frequency which is equal to 0.25 kilohertz, sampling frequency, if the data sampling frequency is given 1 kilohertz, okay, the passband edge frequency is given, sampling frequency is given, okay. Use rectangular window, Hamming window, and Hanning window in the design. So the clue has given, what is the given specification? The cutoff frequency is equal to 0.25 kilohertz they given. So omega c is equal to 2 pi fc by fs. This formula you should know. In the first one we discussed the cutoff frequency given, so by sampling frequency. So how do you calculate this one? So you can calculate 2 pi, what is FC, point the 250 hertz. So 0.25 kilohertz, no. So 2 pi into 250 hertz sampling frequency. What is the sampling frequency? 1 kilohertz they given. So 1 kilohertz 1000 hertz. So you will get so pi by 2. So now how do you draw the frequency response? You should be able to draw the frequency response. Actually you are supposed to do, and give me the clue, you solve the problem. So this is 1, this is 0. So pi by 2 and minus pi by 2. Okay. So this is low pass filter plus omega c, this is minus omega c. Generally plus omega c minus omega c. For this problem we given cutoff frequency and the sampling frequency, then you have to find out the omega c minus omega c is given pi by 2 to minus pi by 2, out of the range minus pi to plus pi. Okay, this is the low pass filter LPF characteristics. So for this, now you use the low pass filter, use spectrum window, Hamming window and Hanning window. You find HD of n properly, you substitute and find HD of n. So alpha value you have to find out. So again one more clue I will give here. HDF is symmetrical. The HDF is symmetry. We need to calculate only. So normally if it is a symmetry, no, HDF is symmetry means, symmetric means need to calculate only n is greater than or equal to then 0, less than or equal to 5 is sufficient. So given m is equal to 11. So what is alpha? M minus 1 by 2. So 11 minus 1 by 2, 5 by 10 by 2, 5. So alpha is equal to 5. Okay. Alpha is equal to 5. So now you rectangular window, Hamming window, Hanning window. Calculate and you can code it by using Scilab also and submit as an assignment. This is an assignment problem for you. In this filter, this one, this is the assignment problem. Design low pass filter for the following specifications: passband, edge frequency, sampling frequency given, use rectangular window, Hamming window and Hanning window in the design. Okay. So deadline to submit. Deadline to submit 10th. Okay, practice now. So that is 17th April. Okay, so the unit was over. Hope that you will understand all the basic fundamentals and how to design a FIR filter for different window techniques. For practice, you can take you can refer John Procky's opening exercise problems. Go to library and refer the reference the prescribed reference books. Have a manuscript and try to solve all the problems. And remember the formulas for the magnitude response for symmetric and M is odd and M is even. Okay, thank you.